Is backpropagation different for CNNs? Imagine teaching a robot to recognize your face or identify objects in a picture. The way it learns is through a process called backpropagation. But when it comes to convolutional neural networks, or CNNs, is this process the same as in regular neural networks? Let's find out. Backpropagation is a method that helps neural networks learn by adjusting their internal settings to reduce mistakes. It uses a math rule called the chain rule from calculus to figure out how much each part of the network contributed to the error. This way, the network can improve over time. In traditional neural networks, backpropagation involves simple calculations with fully connected layers, where each input connects to every output. In CNNs, the core idea of backpropagation stays the same. It still calculates how to change the weights to make the network better. But because CNNs have a special structure, the way it does this is a little different. CNNs have layers that perform convolution operations, where small filters slide over the input data. These filters help the network recognize patterns like edges or textures in images. During backpropagation, the network needs to figure out how to update these filters, not just the usual weights. One big difference is that CNNs share weights across different parts of the input. Instead of having a unique weight for every connection, the same filter is used everywhere. This means backpropagation has to add up the gradients. Those are the signals telling the network how to change, for all the places where the filter was applied. This makes the process more efficient but also more complex because it involves summing over many positions. Another difference is handling pooling layers. These layers reduce the size of the feature maps, which helps the network focus on the most important parts. Pooling layers don't have weights, but they influence how errors flow backward. During backpropagation, the network must map the errors from the pooled output back to the original input positions, which can be tricky. CNNs usually produce multiple feature maps at each layer, each created by different filters. During backpropagation, the network calculates gradients for each filter and each feature map. This adds to the complexity because it involves handling many different channels and spatial dimensions. After the convolutional and pooling layers, CNNs often have fully connected layers. In these parts, backpropagation works just like in traditional neural networks, adjusting weights based on the errors. So, to answer the question directly, backpropagation in CNNs is not fundamentally different. The core idea remains the same. But the way it is carried out adapts to the unique features of CNNs, like shared weights, convolution operations, and multiple feature maps. This specialized process allows CNNs to learn spatial hierarchies of features, making them perfect for image recognition and other tasks involving structured data. Understanding these differences helps in building better models and using them responsibly in AI applications like image generation and recognition.